Okay, kiddos. Here we are. We are doing the review of the Solving Quadratics quiz review. So Monday afternoon, you guys are going to have a quiz on solving quadratics, and so we're going to go over kind of how we do this. So, going to do most of the odds. And away we go. So the first one is completing the square. Now, I do have to say this. I'm going to show you guys a breakdown of how to do these. But when it comes to things like, hey, Cleo. When it comes to things like making sure you have all the steps written down or writing out what the steps are, that's not really what this is. Those things should already be in your notes. If you don't have them, phone a friend, get a copy of them so that you're doing this. Also, a lot of people tend to use the video as an excuse not to do the work itself. The problem with that is that if you don't do the work, and if you don't use if you use it as a replacement for doing the work, yeah, sure, you'll get points, on the 10 points for assignments for, completing the review, but you won't get the points on the test. And keep in mind that your test points are worth 45% of your grade. And your assignment points are only worth 35% of your grade. So it's more important grade-wise that you be able to understand the material, work through the steps, show that you're working through the steps, rather than turn in a, completed review packet. That being said, you should complete the review packet, make sure it's done, use it as a study guide, and then you can also use it on the test as a guide itself. So, normally when we're talking about completing the square, the first thing we do is divide by a. A, of course, is the coefficient of x squared. That means it is the number in front of the x squared. When we complete the square, we can't have a number there, so we divide everything by a. However, on the ones we'll be doing tonight, a is always 1, so it's actually really easy. So, first step is we need to set up the equation to where it looks like ax squared plus bx equals negative c. So we need to make sure that all of the x's are on the left side and the constant is on the right side. Okay. So how are we going to do that? Well, we're simply going to subtract 96 from both sides. This gives me m squared plus 20m equals negative 96. Now, so this is where the term completing the square comes from. And if you don't understand the why or the how of this review really isn't the place to go into that. There is another video called Completing the Square Review. Or just Completing the Square. And go watch that. There are also videos on factoring and, I believe, and other things. So make sure that you are you have the resources, and if you don't understand something or a specific question, feel free tomorrow to drop me an email, and I will do what I can to make sure I can even put a YouTube video up of just that one problem. I've done that before. So anyway, what we're going to do now is we know that our A is 1, our B is 2, 20, so we're going to go B over 2A. That equals 20 over 2 times 1, or 10. If I was going along on the steps on this, this is kind of that pre-work. We go b over 2a squared equals 10 squared, or 100. So the next step would be to add b over 2a squared to both sides of the equation. Well, since I just did that work, I know that b over 2a squared is 100, so I'm going to add 100 to both sides. This then gives me m squared plus 20m plus 100 equals 4. Okay, the next step says to factor the left side to m plus b over 2a. Well, b over 2a here is 10, so we factor the left side to m plus 10 squared. And if I, foiled that out, I'd get m squared plus 20m plus 100 equals 4. So I have m plus 10 squared equals 4. How do I get rid of this squared? Well, I square root both sides. So square and square root cancel out. So I have m plus 10 equals square root of 4 plus or minus 2. So I'm going to subtract 10 from both sides. And that gives me m minus 10 plus or minus 2. So that gives me two equations. It gives me m equals negative 10 plus 2, which is negative 8, or m equals negative 10 minus 2, which is negative 12. So the answer here, is m equals negative 8 or 12. Now keep in mind what that means is that if we had our parabola, because all of our quadratic functions look like a parabola, that its zeros would be here at negative 12 and here at negative 8. So the graph would look something like that. Okay, so moving on. So we're going to look at number 5 now. I'm going to skip number 3 because if you can do number 5, you can do number 3. So what I want to first do is remember how I said we want to put all of our variables over on the left-hand side and all of our constants on the right-hand side. So in order to do that, I need to move the 4r back over. So I'm going to subtract 4r from both sides. So this is going to give me r squared minus 18r minus 32 equals 0. I then want to add 32 to both sides. But first I'm going to identify a as 1, b is negative 18, b over 2a then is negative 18 over 2 times 1, or negative 9. b over 2a squared equals negative 9 squared, or 81. So I'm going to add 32 to both sides. That gives me r squared minus 18r equals 32. So this is the step where we get it to look like x squared plus bx equals negative c. So the next step says to add b over 2a squared to both sides. We just figured out that that's 81. So we're going to add 81 to both sides. That gives me r squared minus 18r plus 81 equals 113. The next step says to factor out the left-hand side to r plus b over 2a squared. That's the whole thing in parentheses squared. Here, b over 2a is negative 9. So we end up with r minus 9 squared equals 113. Square root both sides. That then gives me r minus 9 equals plus or minus the square root of 113. Add 9 to both sides, and I get r equals 9 plus or minus the square root of 113, and those are my answers. Again, if you have any questions, drop me an email. So, number 7. Now, on these ones, what we're being asked to do is solve by factoring. So the steps there, I'm just going to say them out loud really quickly. You should be able to, you should have notes on these. If not, just, listen to this a couple times and write them down. So step 1, put it in standard form. Step 2, identify A, B, and C. Step 3, is multiply a times c. Step 4 is find the factors of a times c that add up to b. Step 5 is rewrite the equation with those factors instead of b. Step 6 is group into two binomials using the associative property of addition. Step 7 is factor out the greatest common factor of both binomials. Step 8 is factor out the common binomial. And step 9 is solve using the zero product theorem. Now, that's if a doesn't equal 1. So that's like on 9 and 11. On number 9, or on number 7, a equals 1. See, there's no coefficient in front of b squared, which means it's just a 1. So here, it's pretty simple. All we have to do is say what two numbers, when multiply, equal 24, but when added together, equal 10. So what we're going to do is we're going to do the factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Well, 4 and 6 add up to 10. 4 times 6 is 24, 4 plus 6 is 10. So we go v plus 4 times v plus 6 equals 0. That gives me, and then I use the zero product theorem, v plus 4 equals 0, or v plus 6 equals 0, and I solve each one of those. And that's going to give me v equals negative 4, or negative 6. If you ever don't understand this, go back, rewatch it, or drop me an email and I'll try and post something explaining it a different way. Number 9, again, so step 1, we want to get it into standard form. That's ax squared plus bx plus c equals 0. Add 5 to both sides, and we have 8r squared minus 49r minus 49. Whoa, too much, too soon. Too far. Okay. So then over on the left-hand side, so I identify A, B, and C. A is 8, B is negative 49, C is negative 49. The next step says multiply A times C. I multiply A times C, and I get negative 392. So now my next step is find the factors of AC that sum to B. Well, what that means is that what, when multiplied together, equals negative 392. Excuse me, still fighting a cold. But when added together, equals negative 49. So what we're going to do is we're going to list all the factors of negative 392 until we get one that sums to negative 49. Now notice that when I'm doing this, I'm making the larger number negative. And that's because when I add them up, I know they need to equal negative 49, which means that the larger number has to be negative. If the sum is negative, the larger of the two addends is negative. So we have 4 and negative 98, 8 and negative 40. No, wait, 7 works. 7 and negative 56. And that's it, because 7 minus 56 is negative 49. So I found my factors of AC, negative 392, that sum to negative 49. It says my next step is to rewrite the original equation, but instead of using B as negative 49, we're actually going to write out negative 56R plus 7R. Then we go minus 49 equals 0. Next step, said we're going to group this into two binomials. We group the first two together and the second two together. We then want to factor out the greatest common factor. If you don't know how to do that, come see me at AOT before the test. So the greatest common factor of 8r squared minus 56r is actually 8r. So we factor out the 8r, and we're left with r minus 7. Second one, we have 7r and 49. We can factor a 7 out, and we're left with r minus 7, which is good because the next step says to factor out the common binomial. Now, if we didn't have a common binomial, we couldn't do that, but we do. So it's r minus 7. We're going to factor that out, and we're left with 8r plus 7 equals 0. Okay, put it in our room. So we have r minus 7 times 8r plus 7. The last step is solve using the zero product theorem. Zero product theorem simply says that if you have two numbers which are multiplied together to equal 0, one of them has to be 0, because you can't multiply two non-zero numbers together and get 0. So we go r minus 7 equals 0, or 8r plus 7 equals 0. Solve them both. One, you add 7 to both sides. The other one, you subtract 7 and then divide by 8. And then you end up with r equals 7 or negative 7/8. Excuse me. Okay, moving on. So that leaves us with number 11. So 11, again, first step is standard form. So we're going to add 4 to both sides and add 5x to both sides. And that's going to give me 2x squared minus 13x plus 6 equals 0. So we identify A as 2, B as negative 13, C as 6. So we're going to multiply 2 times 6 together. That's 8 times C. And we get 12. So we want to know what are the factors of 12, which numbers when multiplied together equal 12. That when we add them together, we get negative 13. Well, because when we add them together, we get negative, and when we multiply them together, we get a positive, we need to think about the value of these numbers, and they both have to be negative. Because only by multiplying two positives or two negatives together can you get a positive product. Since here, we know that they're multiplied together to equal positive 12, but they add up to a negative number, that means they're both negative. So, let's start off with 1 and 12. We're done. That was easy. So we have negative 1 times negative 12 equals 12, and negative 1 plus negative 12 equals negative 13. So we then have 2x squared, same process, minus x minus 12x plus 6 equals 0. I want to group the first two and the second two together. Now these are a little bit tricky when we have two negatives, like right here, negative x and negative 12x. When we're grouping them, we want to put a plus in between those two groups. And then we're going to factor out an x. And that's going to give me x times 2x minus 1. Plus, factor out the greatest common factor of negative 12x plus 6 is 6. Factor out actually a negative 6, and then so I can match up that 2x minus 1 equals 0. Factor out the 2x. Factor out the 2x minus 1. And we're left with x minus 6 equals 0. Set both of those equal to 0. 2x minus 1 equals 0. Or x minus 6 equals 0. Here I'm going to add 1 to both sides. 2x equals 1. Divide by 2. X equals 1 half. Or on the other one, I just add 6 to both sides and get x equals 6. So again, what that represents is where the graph hits the x-axis. So, these next ones require me to use the quadratic formula. So, again, the steps would be 1, put it in standard form. 2, identify A, B, and C. 3, plug those A, B's, and C's into the equation, the quadratic equation. Or formula rather, and then so plug them in, solve for the discriminant, write out the two problems separately and solve if possible. So here A is 2, B is 1, and C is negative 36. So plug those in. We end up with negative 1 plus or minus the square root of 1 plus 288 over 4. That gives me negative 1 plus or minus the square root of 289 over 4. Plug that into a calculator. The square root of 289 is 17. So we have negative 1 plus or minus the square root of 17, or rather just 17, over 4. So if I go negative 1 plus 17 over 4, I get 16 over 4, or 4. If I add or subtract 17, that gives me negative 18 over 4, or negative 9 over 2. And those are my answers. Okay, moving on. Okay, so I'm going to actually show you a little shortcut on number 15. And then after we do number 17, I'll go back and do 13 with the quadratic function. I know that seems a little silly, but it'll make more sense. Okay. Sorry. I had to take a quick cough break there. Okay. So, what we can do here is add 21 to both sides and go 3m squared equals 21, divide by 3, and we get m squared equals 7. We can then square root both sides, and we get m equals plus or minus 7. Okay, so we're actually going to do that one twice, but we're going to do 17 first. So, hey girls. I like how you're acting like I haven't been home all day. Anyway. Okay, so number 17. First thing we want to do is we want to subtract 11 from both sides. That's going to give us 3n squared minus 8n minus 20. So when we go and plug it into the quadratic equation, we get negative 8 plus or minus the square root of negative 8 squared minus 4 times a, which is 3, times c, which is negative 11, or negative 9. So c, which is negative 20. And we're going to put all of that over 2 times 3. So that's going to give me 8 plus or minus the square root of 64. And then we have negative 4 times 3 times 20, which is going to be plus, actually, 240 over 6. So that gives me 8 plus or minus the square root of 304 over 6. So to figure out whether or not, so I know 304 can be broken up a little bit. Because if I have the square root of 304, that can be factored out to the square root of, let's say, 4 times 76. Okay. 76 can further be broken down into 4 times 16. And 16 is 4 times 4. So Had to go back and check my math there. It's actually 4 times 19. So what I have here is the square root of 4 times 4 times 19. I can rewrite that as the square root of 4 times the square root of 4 times the square root of 19, which gives me 2 times the square root of 19, or 4 radical 19. So now back over here, I can rewrite this as 8 plus or minus the 4 radical 19 over 6. 8, 4, and 6 all divisible by 2, so I can reduce this to 4 plus or minus the square root of 19 over 3. Okay, so that would be that answer. Now, the reason that I want to now go back and do number 15 is to show you how that would look like if we use the quadratic formula, which is what it said to do. So, A is 3, B is 0, C is negative 21. So that gives us the square root, 0 plus or minus the square root of negative 4 times 3 times 21. You literally just went outside. What the hell is wrong with you? Go. So we multiply that out, and that goes over 2 times 3. So that gives us plus or minus the square root of 252 over 6. So now we want to kind of do what we were just doing. 252 is equal to 336 times 7, or the square root of 36 times the square root of 7, or 6 times the square root of 7. So that means that we have plus or minus 6 times the square root of 7 over 6. 6 is canceled, so we have plus or minus the square root of 7, which is what we had when we did it the other way. So if it says solve, feel free to do it the other way. If it says use a quadratic formula to solve, then you're kind of stuck doing it this way. Oops, well, that's the answer there. Okay. So next, we are adding, subtracting, multiplying, and dividing radical numbers. Remember that all complex numbers need to be in the form of a plus bi, where a is the real component and bi is the imaginary component. So when we have an addition or a subtraction problem, as we do here, what we want to do is we want to add our real components, or in this case, subtract our real components, and then subtract our imaginary components. So we're going to go 2 plus negative 7 plus, and I know that's weird to have a plus there, but we're adding, and then we're going to subtract the components, 8i minus 5i. So that's going to give me 2 plus 7 is 9, and 8 plus 5 is 13i, or 12i rather. No, 13i. $25. So the 4, notice the 4 is the only real thing we have there. So we're going to kind of set that aside. Then we're going to add we have 3 imaginary components here. 8i minus 3i plus 8i. And we add all those together. 8 minus 3 is 5. 5 plus 8 is again 13. So we end up with 4 plus 13i. 27. 27 is a little... It's not trickier, you just have to be more aware of what you're doing. So here we have 2 binomials that we're multiplying together, and the way we do that is foiling. First, outer, inner, last. So that means we take our first number 5, multiply it by the first number of the other one. We then take the outside numbers, 5 and negative 7i. We'll then take the inside numbers, and then the last numbers in each of the binomials. So FOIL, we multiply our first ones together. What? And so we're going to go our first ones together, 5 times negative 7. Our outer ones together are 5 times negative 7. Be quiet, I'm working. Come here. Mommy, come here. Rama, come here. Rama. She's just laying on the floor, wagging her tail, whatever. Come here, Rama. Our inside ones are 7 and 7, negative 7i. And our last ones are 7i and negative 7i. Come here. So we go 5 times negative 7 is negative 35. Do you want to go to bed? Okay, I'm going to pause. Okay. So 5 times negative 7i is negative 35i. 7i times 7 is negative 49i. And 7i times negative 7i is negative 49i squared. So that gives us negative 35 minus 84i minus 49i squared. Now remember, I squared is negative 1. So this gives us 35 minus 84i. Ugh, animals are being loud tonight. So that gives us negative 35 plus, or minus 84i, plus 49. So negative 35 plus 49 is 14. So we get 14 minus 84i. And that's our complex number. Same idea for number 29. Our first ones together, negative 1 and 8. And then we're going to do negative 1 and negative 6i. And then negative 6i and 8. And negative 6i times negative 6i. So we multiply all those together. We get negative 8 plus 6i minus 48i plus 36i squared. That gives me negative 8 minus 42i minus 36, or negative 44 minus 42i. Okay, now for multiplication, or for division, what we're really trying to do here is rationalize the denominator so that we can put this into a complex number format of a plus bi. Right now we couldn't separate the real component from the imaginary component because the denominator is imaginary. So if we split this up to negative 2 over 6i plus 7i over 6i, we'd have some issues. Okay, so this is what we would do. We're just going to multiply both sides by I. We're by I over I. That's 1, so we don't change the value. Okay, so the denominator is then 6i times I, or 6i squared. This is going to give me negative 6. The numerator is negative 2 plus 7i times I. So we distribute that I, and we get negative 2i plus 7i squared, or negative 2i minus 7. Flip that around so that the real number is in front. And we have negative 7 minus 2i over negative 6, or negative 7 over negative 6 minus 2 over negative 6i. So we have 7 over 6 plus 1/3 I, and that's my answer. Real component, imaginary component. Okay. Okay, next. Same general idea. Multiply both sides by I. That gives us a numerator of 6i minus 3i squared, a denominator of 2i squared. I squared becomes negative 1, so we end up with 6i plus 3 over negative 2. Rearrange it so it's real first, then imaginary. Separate our real and our imaginary, so that gives us negative 3/2 minus, and then 6 over 2 is just 3, so minus 3i. And that would be our answer. So, 35 gets a bit trickier because we now need to do what's called multiplying by the conjugate. Now, we went over this a couple times in class, and your understanding of it probably varies directly with how much attention you are paying. So what we're trying to do here is get rid of the I. So what we do is we multiply by negative 5 minus I plus I over negative 5 plus I. Okay? Because that's 1, so we're not changing the value. So watch what happens. When we multiply 5 times negative 5 plus I, we distribute the 5. We get negative 25 plus 5i. Okay. Now watch what happens on the bottom. We have negative 5 minus I times negative 5 plus I. When we FOIL that out, we get negative 25 minus 5i plus 5i minus I squared. The two middle ones cancel out, and we have 25 minus I squared. I squared becomes negative 1, so this becomes 25 plus 1, or 26. So we now have negative 25 plus 5i over 26. Notice how we got rid of the I in the denominator. Break this apart. We now have our real component and our imaginary component. Okay. Same general idea for number 37. We're going to go 8 minus 7i times 8 minus 7i. And when we do that, we get 56 minus 49i. And now on the bottom, when we FOIL, we get 64 minus 56i plus 56i minus 49i squared. That gives me 64 plus 49, or minus 49 times negative 1, which is what I squared is. 64 plus 49 gives me 113. So I have 56 over 113 minus 49 over 113i. Okay. Graph each number in the complex plane. So remember, what we do is we graph the real component as the x-axis, basically, and then the imaginary component as the y-axis. So here, our real component is negative 5. So we go over to negative 5 on the real axis. And then our imaginary component is negative I, or negative 1i. So we go down 1. And that's our point, negative 5 minus I. 41, negative 2 plus 3i. So we're going to go over 2, up 3. And that's 2 plus 3i. It's that simple. Here, we need to look at the point and figure out what it is. So here, we went over 4 on the real, and then down 4 on the imaginary. So that is going to give us, we went 3 over on the real, sorry, and 4 down on the imaginary. So that gives us 3 minus 4i as our answer. Here, we go negative 5 on the real, and nothing on the imaginary, so that's negative 5 plus 0i, or just negative 5. So absolute value of each complex number. So remember that we know every complex number is in the form of a plus bi. So the absolute value of the complex zero, which is how far away it is from zero, is actually a use of the distance formula, or the Pythagorean theorem. And so it's actually a squared plus b squared. Again, I'm pretty sure I did a video on complex numbers, so if you don't fully understand it, go back and check that out. I know I did a video on complex numbers. So we have here a equals 0, b equals negative 1. So square root of 0 squared plus negative 1 squared. 0 squared is 0, negative 1 squared is 1. So that just gives us the square root of 1, or 1. Boom. 49. A equals negative 10. B equals negative 7. So the absolute value of that is the square root of negative 10 squared plus 49, or negative 7 squared, or 100 plus 49, or 149. $51. A equals negative 5, B equals 10. So that gives us negative 5 squared plus 10 squared, or 25 plus 100, or 125. Now here I can actually factor out 25, which means that I can make 125 rewrite as the square root of 5 times the square root of negative of 25. And 25 is actually the square root. That's a perfect square. So we can write that down and just say the answer is 5 radical 5. And that's it. Please look at this. Please study. The points for quizzes and tests are super important. So hope you guys had a nice weekend. Study and bring your A game on Monday. Have a good night, y'all.